What is the final pressure of a gas originally at 30.0 liters and 250.0 torrs if it is compressed to 15.0 liters at constant temperature? Boyle's law is applicable to this problem as it relates volume and pressure. Boyle's law says that at a given temperature, the pressure and volume of a gas are inversely proportional. This means that, provided the temperature is constant, the higher the pressure, the smaller the volume. The lower the pressure, the larger the volume. At this point, we can eliminate choices A and B. Since the volume shrunk from 30 liters to 15 liters, we expect the pressure to increase. We therefore expect the final pressure to be higher than the original pressure, which is 250.0 torr. 125 torrs is less than 250 torrs, and 235 torrs is less than 250 torrs. Mathematically, when two quantities are inversely proportional, we say that their product is equal to a constant. In other words, we can say that P times V is equal to a constant. If we refer to the initial pressure and volume as P1 and V1, and refer to the final pressure and volume as P2 and V2, then we can also say that product P1 times V1 is equal to the product P2 times V2. Solving for the final pressure P2, we get P2 is equal to the original pressure P1, which is given as 250.0 torr, times the original volume V1, which is given as 30.0 liters, divided by the final volume V2, which is given as 15.0 liters. Carrying out the indicated calculation gives us 500 torrs. Therefore, the correct answer is D. You can see that cutting the volume in half from 30 to 15 liters causes the pressure to double from 250 to 500 torrs. In case you can't remember whether pressure and volume are directly proportional or inversely proportional, you can figure it out by starting with the ideal gas law, PV equals nRT. You can see that for a fixed amount of gas, constant N, in a fixed temperature, constant T, the right-hand side of this equation is constant. Whenever the product of two quantities is constant, we say that they are inversely proportional. If one goes up, the other must go down by the same factor. If one is doubled, the other is cut in half. If one is tripled, the other is reduced to 1/3 of its original value.